Hello, good morning. My name is Bart van Mulders, and I welcome you to our second webinar in a series of 5. This one is called DataVault 2.0 Advanced Data Modeling in Azure. I will guide you to a brief introductory before handing over to the two presenters of today. I will briefly explain who we are, and then the agenda will continue guiding you to the basic DataVault 2.0 principles, and you will see some hands-on and quick modeling examples from a developer's and a business perspective. A very brief introduction to Micropole Group. Micropole Insight is a Micropole Group initiative directly aiming at supporting our customers in Microsoft technology all over the world. In fact, we have offices in Belgium, China, France, Luxembourg, the Netherlands, and Switzerland. And the Micropole Insight initiative was launched at the beginning of 2020. And despite of a difficult COVID year, we have been able to set up and launch a very experienced team and are active at 7 customers already. Basically, what we are aiming at with Micropole Group is based on 3 different pillars. We work a lot around digital experience via our WIDE initiative, WIDE agency, which is based in Switzerland. But from Micropole Insight, we mainly work on data governance and architecture, data intelligence and performance, and as mentioned before, mostly from a Microsoft perspective. The services we bring to the market are, first of all, value discovery, where together with our customers, we try to strategize around bringing data and analytics to the cloud so we can organize brainstorm sessions and half-a-day workshops. Secondly, once we've defined the strategy, we are able, with our technical people, to effectively bring analytics to the cloud. And we're working mainly around Azure, setting up a basic architecture, doing data modeling design, and performing migrations for our customers. We also have an off-site or on-site data visualization design studio, where we support data visualization solutions mainly based on Power Apps and Power BI, but we can also support our customers in Tableau and, if necessary, Qlik. Our 4th pillar is the Data Ready Enterprise, which is a series of workshops we can prepare to define together with our customers the business case around AI, and then furthermore do the development based on technologies such as Python, R, and so on. This will conclude my basic introduction. I will now hand the floor to our 2 speakers, Jan van Humbeek and Egon van der Rijt, who will briefly introduce themselves and then move on with the presentation. I wish you a very interesting presentation from Jan and Egon, and we will be glad to get in touch afterwards if you have any remaining questions. Talk to you later. Bye.
Okay, hello. My name is Jan van Humbeek. I am an Azure data engineer. I've been working with the Microsoft Data Platform for over 10 years now. My main occupation has been business intelligence, and of course the development that, the development side that comes associated with that. At home, I am a servant to 3 cats and a dog, and in my free time, I like to go hiking, biking, and also a bit of gaming.
Okay, my name is Egon van der Rijt. I'm a Azure data architect and also Azure data engineer. I've been working with the Microsoft Data Platform for more than 20 years. I first started as a DBA, and later on I did also more and more BI projects. I'm a father of 2 sons, and if I have some free time, I like playing around, playing guitar, playing paddle, and playing around with IoT devices. Okay, so let's start this quick session with a quick historical overview of the BI architecture types in the past. If we look back on how the data integration was done in the past, we see that there are 2 big approaches. The first one is the approach of Bill Inman. This is kind of a Big Bang approach. It starts by designing an enterprise data model from the CIF, and the CIF is a corporate information factory, a kind of framework that focuses on data warehousing. And this CIF is normalized enterprise data model, so it's really detailed modelized. It all integrates all data into the integration layer before starting the delivery of the data in the data marts. So the integration layer is mostly non-queryable, or it is at least not optimized for it. Only the data marts are really optimized for the querying. The CIF is very detailed. It's a low-level data is stored in it, and the data mart contains only the summary of the data according to the needs. So this modeling, the complexity can really grow exponentially, and with the number of sources you add. This approach, probably sounds familiar to a lot of you people, because this is kind of the way that things was done in the past, kind of classical data warehousing. The second approach is the approach of Ralph Kimball, also very known. It's an approach centered around the notion of the federated data marts. So its typical characteristics are in this approach are that it emphasizes the data mart. So it's designed with the focus on the results, the data marts. It focuses also on one source or business process at a time. The data marts are deployed incrementally and integrated using conformed standardized dimensions. And the data warehouse is only the sum of the data marts, and there is no CIFs or no EDH, no enterprise data hub layer. So it uses a flat architecture consisting of a staging area and data marts. And this staging area is largely non-persistent. So the data marts need to contain both atomic and the summary data at the lowest level in detail if you want to keep it. The ideal architecture would be a kind of a mix of both approaches. With the iterative modeling as defined by Ralph Kimball, and the integration layer with the enterprise data warehouse as defined by Bill Inman. Like, for example, the EDH and enterprise data hub can be. When I started myself doing big data projects in the cloud, like I started 4 years ago, the target of going to the cloud was to create an enterprise data hub, which needed to be able to keep all history of data. It needed also to benefit of the agility of the cloud. During this project, we looked also for a way to offload data with a minimum of constraints and rules on the imported data. And the data needed really to be stored as close as possible as to the way it was received from the sources. As a last target, we also had a constraint to have more data governance and more data lineage. We experimented with different models at that time, and like the classic Kimball and Inman one, and also did took different versions of the 3NF, the third normal form, and the ERV modeling, which is entity attribute value modeling. But at the end, we used the DataVault because it had, besides the pure modeling technique, also a complete methodology to improve performance of the imports. Now I will give the word to Jan Beck, who will introduce you to the concepts of the DataVault.
Okay, thank you, Egon. The DataVault modeling basically consists of 3 basic concepts. So first and foremost, we have the hubs. The hubs are they contain the unique list of all the business keys. So the business keys such as a customer ID or an order ID. Business key is, of course, a key from the source that has a functional meaning for end users or business users and is known by them. The links next to that, they represent all the possible relationships between the hubs. So that means any transactions or any parent-child relationships, for instance. They also store the keys from the hubs to define that relationship. And then next to hubs and links, we also need to have some descriptive data, which is being stored in satellites. So the satellites, they contain all the context information for hubs and or links. They always have a validity period, so with a valid from and valid to indication. And the attributes that we can find in the satellites, they are split over different satellites according to, for example, the frequency of change. Now, when you start to create your DataVault model, you can follow these following creation steps. So first of all, you model the hubs by identifying and selecting the different business keys. Secondly, you will model the links by identifying all the transactions or the parent-child relationships that happen in the source. And thirdly, you will start modeling the satellites. Now, when modeling all these things, you also need to strictly respect the following rules. So hubs cannot be linked directly to other hubs. So they must be connected through links in the middle. Links can be connected to other links, and the satellites, they can be connected to either hubs or links. Satellites, they always contain the timestamp or a reference to the validity period. And the data in those satellites is separated based on the type of information and the rate of change. Now, if we talk about DataVault, we need to distinguish DataVault 1.0 from DataVault 2.0. So DataVault 1.0 was publicized in 2000, which was mainly axed on the modelization part. So it defined the foundation, the hubs, the links, and the satellites. And that all changed, or at least iteratively changed with DataVault 2.0 in 2013, where they also included a complete methodology, as Egon previously mentioned already. So in the methodology, they also include an agile implementation by iteration approach. Next to that, it also contains some new features based on into the modelization, such as the hashing of business keys to avoid the expensive lookups of technical keys. And now Egon will be deploying the DataVault into the cloud.
Okay, thank you, Jan. So let's now take a look more in detail to see why DataVault really fits with our Azure cloud. If we look at the role of the DataVault in the complete architecture, we see that in the center between the import and the consumption, really the integration layer. We discussed this architecture that you see here in our previous session. If there are people that were not able to join that session, you can always find the link to the previous session in our chat window. If you take a look at the first part of the architecture, this is the part of the batch and streaming layers that perform the ingestion. At the top, we see the batch replicated data, which can combine the data from different sources and puts it in a staging environment. At the bottom, we have the streaming data that can be service-oriented data, or it can also be enterprise service bus data. If you take a look at the second part of the architecture, there we have our enterprise data warehouse or enterprise data hub. And this consists of the raw vaults with some cleansed or raw data and the business vaults. This can be a virtual or materialized layer to combine or focus specific data for specific data or a specific business case. All this data can also be easily transferred from or to the NoSQL on the bottom from the data vault. So for example, if you want to have a 360 view of a customer or another entity, you can store it there, and it can be front-end or back-end facing. This part contains our data integration layer and our big data layer of our architecture, and can also contain our data science layer. If you take a look at the last part, this is our information delivery layer. In this part, this is the part where the data is presented to the end user, for example, in dashboards. It's also the data where it can be visualized, and we can also visualize data lineage. And it's a part to present an overview of your integration. So there you can see with your error marks, for example, to see what data is processed, how much was successful, how much data gave errors. In this slide, we see that the characteristics of DataVault really match with the characteristics of the cloud. In my personal opinion, I think that the flexibility of DataVault matching with the agility of the cloud, together with the historization and metadata integration, are really the most important one. I'm not going to discuss all of these matches, but if you want to check it in detail, you can always download the handout of this presentation and take a look at it yourself. In this last overview of the match between the DataVault and Azure, I want to give a quick overview on how this model maps to the Azure resources. So at the left side, we have our data ingestion and orchestration, where we have Data Factory with the integration runtime. Then we have our streaming data from our service-oriented and ESB, which goes via the Event Hub and can also be done by streaming analytics. Or you can also use Databricks to handle the streaming data. You will see Databricks can be handled or used in different phases of the architecture. For example, Databricks can also be used in the data processing, and there it can be combined with the Azure functions. Our data storage will be done in the Azure Data Lake Storage Gen 2, but we can also store it in a SQL DB, where we can, for example, store our metadata for doing the modeling. And we can also store it in Cosmos DB for the NoSQL part. Yeah. Then we have our Synapse. Synapse can also be used to store data, so it has also a data warehouse in the background. But Synapse can also be used as a presentation layer, and then we talk about the Synapse workspaces. And as the last part of our data presentation layer, we have also the Power BI. At Micropole Insight, we've built a DataVault engine. This is a framework built in the Azure with the Azure components like the ADF, the Azure Data Factory, Azure Functions, and Databricks, which has its metadata in an Azure SQL DB stored that defines which sources must be loaded and how those sources will be filled in DataVault integration layer. Okay, so now let's have a quick overview on how and what the enhancements are on DataVault and what it can bring extra to you. What are the advantages of using DataVault if we compare it with the 3NF, the third normal form? Well, DataVault is based on the third normal form, but there are some issues with the third normal form. So, for example, it doesn't support well the data historization. It creates dependencies between the entities, and it does not grow the model agile. DataVault, that's on top of it, decoupling of the business keys and the contextual information, so with the hubs and the sets that we saw. It also adds the decoupling of the relationships between business keys like parent-child or transactional relationships with link tables. And it calculates also extra the hash keys and the hash diffs to improve the performance and the coherence. Of course, DataVault is no holy grail, and it has its attention points. So you need really carefully choose your right business key, but that's with every modeling technique. And the model can also quickly grow to something really big with a lot of tables, like a kind of data swamp, if you are not if you do not pay attention to it. So the most important benefits are the enhanced decoupling. It makes it more dynamic. And if you have changes, the impact is low. For example, an additional source for the same entity or hub can be quickly added, and you don't have to modify your existing entity. So you don't have to merge both sources into one big table that covers both needs. It supports also the self-service BI. If you create a business vault, materialized or virtualized on top of it. And as I already told you also, it matches with the NoSQL. You can really very quickly load in or to the NoSQL. Okay, so let's dive into it a little bit and go to a quick modeling example. Let's start with a normal OLTP source model. If we look at this model, we see our categories, products, really familiar design for everybody, I think, where we have our foreign key relationships and from which data source we want to load the data into our integration data layer into our data vault model. So if we start with the data vault modeling, the first thing we do is the hub identification. So we need to start finding our business keys or our basic business concepts. Then we need to create a surrogate key and then define additional metadata, for example, load date, source system, that kind of things that we really want to add that can also afterwards serve our data lineage and so on. If you look at this example, we have, for example, our hub products. We see our product SK, that is our surrogate key, the one we have generated ourselves. Then we have the product ID, which is the business key we receive from the source and we store. And then in this case, we have only a load date and a source system. In the second phase, we are going to identify our links. A link is a unique identifiable business element relationship. And it can define a foreign key, it can be an event, an association, or a hierarchy. And now I'm trying to get to my, yeah, okay. So over here we see, for example, our link order. And in the link order, we have our link order SK, which is again a new owned surrogate key. We have a shipper, customer, and employee SK that are all the surrogate keys from our hubs, so from our hub employee, customer, and shipper. And then we have again our source system and load dates. If we take a look at the last phase, there we are going to define our satellites. These contain our non-identifying business elements for a specific point in time, so it's really time-driven context, and it contains the attributes of our hub or our link table. At this level, we will also add a hash diff column to fasten the check for the changes and to fasten the loads. If we take a look at this detail, then we see, for example, this supplier satellite, which has its surrogate key that links to the hub supplier. We have a valid from and a valid until, which serves the historization. Then we have all our attributes like company name, contact name, all those things. And then at the end, we add our metadata, so the load date, source system, and our hash diff. I now hand over the word again to Jan, who will give you a view of the data vault from different perspectives.
Okay, thank you, Egon. So as mentioned before, the data vault is a very repeatable solution. So all the data vault elements, they have their own way of loading data. So from that way per type of element, you can of course distinguish a pattern. That pattern, you can then translate that into a template to generate your entire ETL load based on just some metadata. The data vault is also very manageable. So when you try to implement another source, You will just have to extend the existing data model already. So there are no structural changes to the existing elements in that regard. That leads to a very organic growth, which means that any change that you need to make to your DataVault model is just an addition to your metadata. And if coded correctly, just by a click of a button, you could generate your entire ETL load and even missing objects. Slide, yes. Now, of course, there's not only benefits. There are also some hindrances. So as with any new data model, it takes a while to get to know the ins and outs. DataVault has quite a steep learning curve. It has its own structure with a lot of tables and a lot of relationships. And getting the data out takes some practice, but in the end, also that is a very repeatable pattern. Furthermore, the data vault can become very complex. So everything is connected. Data from only a hub, only a link, or only a satellite is by itself rather meaningless. The context is created by joining them all together, which means that it can also become very impractical for querying, and it's not really to be handed directly to business users or end users. A small subset might seem doable, but the complete model will be frightening for them and sometimes even you at first. Now, last but not least, there is also a storage cost involved. So having all the data timestamped in those satellites literally also means all the data. There's two sides to every penny. Having all the data all the time means that you can reconstruct points in time for your data, but it also means a lot of storage capacity. Now, there is also a cherry on top. DataVault's loading pattern is very performant. So DataVault 2.0 relies on eventual consistency. During the data load, there might be some gaps, but when the entire load is done, everything will link together. Eventual consistency is reached through that hashing algorithm. So the surrogate or technical key that is used in the DataVault elements, such as the hub and the satellite, but also even the link, is a hash of the business key that we defined in the source. And as you can see here, both the hub shipper and the sat shipper are both loaded from the same source dataset, the table shippers. They can be loaded in parallel, and the hash, so the shipper SK, is basically a hash of that shipper ID. So since both tables are loaded from the same source data, you can just apply the same hashing algorithm to the shipper ID, and both tables will have the same shipper SK inserted into them during the data load, linking the data together in the end. Now, of course, next to a developer's perspective, there's also business value involved. So the data vault, it makes near real-time loads possible. So implemented correctly, the data vault load can be triggered through an event launched from the source system to load new data, because who else knows that new data is inserted but the source system. Having near real-time data is amazing for ad hoc checks, interventions, etc. Furthermore, it's also decoupled from business rules. So the physical data vault only contains the raw data, which is exactly the same as the source system. You have a very rapid return on investment. New data mart objects can be built immediately on top of the data vault. So for any new features requested by business, the raw data is most of the time already there. It's already in your data vault. You just need to apply the appropriate business rules and load the new data mart objects. No data reloads need to happen. And then last but not least, compliance. Since all your data manipulations are captured, it forms a great way to trace it back to the source system. This way it can be used as a pillar for data quality as well. Now, some scenarios. you can immediately trace bugs back to the source data. So if business users come to you like, hey, I'm noticing some figures here that seem incorrect, you can immediately trace them back to the raw data or to the business rule implementation that is causing the bug. And then another part which is slightly related, data is wrong one day, right the next. Since all data is timestamped, you can immediately check which data manipulation caused the error and subsequently also caused the fix. Again, rapid bug fixing. A bug can be easily squashed by creating a virtual data mart object with the fixed business rule. No reloads of the data mart are necessary since all the raw data is still in the data vault. So in the case that you have a materialized data mart, you can first mock it up in a virtual data mart object, which business can validate before you actually create that materialized physical object. And that concludes our presentation, and we will dive into the chat box and see if there are any questions right now.
Okay.
Let's see. So we have a question from Aagje. What kind of Flemish companies have successfully implemented DataVault?
Yes. The first project I did with DataVault was at Euroconsumers. They are located in Brussels, so there I experienced, and that's also the story I told with the different models. And there at the end we chose for the DataVault modeling, and it's in production there. I also did a project at PSA in Antwerp. They also chose for the DataVault modeling. So there are really already a couple of projects that were done successfully with this DataVault architecture and where we successfully integrated. I don't know if you have some more experience.
Well, my current customer, so currently I'm working at the National Lottery. We are also currently we have a complete implementation of DataVault 1.0 right now still. We are in the process of migrating that to Azure. And after that migration has succeeded, we will be transforming it to the DataVault 2.0 approach, changing out the identity keys by the hash keys, and therefore having that parallel load performance as well.
Okay,
I hope that answers that question. We have another question from the audience. I don't yet see the name here. So if you use SQL Server as a database engine to store the data vault, do you use the hash keys as clustered index, or what is your strategy on choosing the clustered index?
I don't know if you have...
Yeah, so currently we actually with the migration that I'm doing at the National Lottery, we actually revised the indexing approach while doing the migration towards Azure. So on premises, we were still using SQL Server 2012, which did not yet have like clustered column store indexes and everything. So during the migration to Azure, in general, we tried to use clustered indexes on top of the business keys instead of hash keys in regards to DataVault 2.0, because of course if well, I'm going a bit out of topic here, but a clustered index also means the way data will be stored on the physical disk, and a hash key will of course cause some fragmentation on the disk. So every new data that arrives, if the hash key is calculated, it will get inserted into the clustered index at different positions, which is not what you definitely not what you want. So clustered index most of the time on the business keys, and combine that with some partitioning approach. In general, because you are using DataVault, you also have some audit information, and you have a load date. So at the lottery, we implemented partitioning on that load date so that our clustered index is also again partitioned based on the load date, and it limits that fragmentation even further. And then, of course, if you are using any version of SQL Server that supports clustered column store indexes, I would highly recommend to put your links in a clustered column store index. At least the links that have over 20 million records, which in our case is definitely occurring more than once, because you can definitely have some performance gains from that. So I hope that answers your question. I think it was from Tim. Yeah. And we have another question from Tim. Which technical optimizations do you use for querying temporal satellites?
Technical optimizations, yeah, it depends a little bit. If you want to query your data, then you always have to, one way or the other, materialize your data. So if it's, I don't know, temporal satellites, you can also again materialize them. I don't know in this case specifically what you want to do with it, so we have to take a look at it case per case. What is the target? What is the amount of data, of course? How do you want to retrieve it? So I don't think it's a little bit the default answer, and it depends. That's a quite often answer. So it depends really on the case and the data you want to optimize and how it looks like. But in my experience with giving back the data from the data vault to the end user, yeah, sometimes we have to materialize it. We can use materialized views for it, where it's automatically materialized for you when the data changes in the background, or you can do it yourself. So there are some different approaches on that. And it's kind of really performance tuning at that time, so it's a little bit specifically case per case. If you have a specific case, you can always let us know, I would say, and then we can also take a look at it.
Yeah, as an addendum to that as well. So if you're creating your temporal satellites, let's continue on with the approach that you are storing your data vault in SQL Server. You would normally, for all your satellites, you would put a non-clustered index as well on top of your your key, combined with the end date of your validity period. So that also solves in part the querying of the temporal satellites, where the indexing will make sure that you have the latest valid data based on that load end date. And apparently we have a very active audience today. So we have a question from Tioma, or Choma. I don't know how to pronounce your name. I'm sorry if I pronounced it wrong. So is the implementation metadata driven? In my current approach at the lottery, everything is indeed metadata driven. So we have some sort of procedures that load the data from our staging source towards the data vault. So we have a metadata layer that basically includes all the information, and then a generic loading pattern that iterates over everything.
Yeah. Maybe also in addition to that, the approach we have with Micropole within Micropole Insight is that we have the data vault engine in the cloud. And as I already mentioned very briefly, it consists of Azure Data Factory, Azure Functions, and so on. And there we have also an Azure SQL where we store our metadata, and there it's really metadata driven. So there you define the sources you are going to load, and if source is not defined in your metadata catalog, then it will not be picked up. But if you define it, then you can define, okay, how do I need to handle it? What will be the schema to put it in, and then it can based on that metadata, it will handle the data within the framework, as we call it, the DataVault engine we have. So yeah, we can really base the integration on the metadata you store in. We do it in a SQL database. I know that some people store it in YAML files. You can choose it yourself. That's a way of flavors what you yourself prefer.
Okay, and then we have another question from Tim, who wants to know if we use PIT tables often. So for those in the audience who don't know what PIT stands for, it stands for point in time tables, which is basically a sort of snapshotting table where you store the state of your DataVault objects at a certain point in time. Let's say you want to have a quarterly overview, you make a point in time snapshot of that quarter and you store it somewhere so that you can always have that available directly for, let's say, quarter by quarter comparisons or anything. As I mentioned before, at the lottery, we are still using DataVault 1.0. Point in time tables were not really included in that methodology yet. Plus, at that project, we don't really have the need for point-in-time tables right now. Business hasn't defined any use cases for that, but I can imagine that in the future we will be using those snapshots precisely for the approach that I mentioned before, like quarter-by-quarter comparisons, or well, in the case of the lottery, if there's like a giant Euro Millions jackpot, we would probably want to do some snapshotting exactly when those Euro Millions are happening, so that we have some comparisons on entries on well, tickets sold and such. I don't know, Egon, if you have any experience with point-in-time tables at your customers?
Yeah, we did some experiences with it as well, with PIT and spot tables, but in the end, we always, for the last project we did, there we ended up all data in the data mart, so there we materialized it there, so also historization and point in time works done there, so we use it, but not very often. But it was more experimenting with it. Okay, are there further questions?
I think that's all for today. We can wrap up here. So we would like to thank you for your attendance today, and we would like to remind you that we have 3 more sessions planned right now on our agenda. So 2 sessions will be about continuous integration with Azure, part 1 on October 29th and part 2 on November 26th, where we'll be discussing the CI/CD related components. And then right in the middle of that, we have a data orchestration webinar, how to orchestrate the workflows in Azure, on November 12th. After this webinar, you will be receiving an email as well containing this agenda. And at a later point in time, closer to when those sessions will be happening, we will be sending a reminder with the registration link attached.
Okay, thank you very much. See you later.